Welcome back. Today, we're going to be talking about arrays. Let's begin. Remember those animal shipping containers from the last lesson? Well, let's build on that idea. Today, we're going to be shipping out multiple containers of the same size and be placing them into one large container for ease of transport. In order to maximize the space of the large amalgamated container, we need to stack these small containers, and thusly, they must all be of the same size. Since we are compacting these containers, we no longer need to name each animal's container. Instead, we will name the larger container. Let's call this one small animals. If we want to identify a specific cage or element within that group, we can use their index. Think of indices as an ordered list, except that the number must always start at 0. As you may have guessed, these larger containers are analogous to arrays, containing variables of the same data type. There are no exceptions to the like data type rule. There is no such array that contains some integers and some floats. It must be all of the same. The thing that people most commonly mess up is the indexing part. If you want to create an array called numbers with 5 integers in it, then the index of the last item will be at array 4, since the first item is at the index array 0. With arrays, they always start at 0 and go from there. If you were to try to access array 5, you would be thrown an error. Another concept that messes people up is 2D arrays, but I promise you they're pretty easy once you can visualize it. One way you can think of indexing 2D arrays is that you're working in the 4th quadrant of the Cartesian scale. Only difference is, the y-axis is using absolute values. Another difference is that instead of the typical coordinate system of x-coordinate first, then y-coordinate, it's reversed. A 2D array is referenced by the array name, and then the row index, followed by the column index, which would be like referencing y first before x. A bit confusing at first, I'm sure. But make your own programs, play around a little bit, get really comfortable with it, and before you know it, it'll be like second nature to you. So for the sake of visualization, let's say we have this 2D array which we'll call my array. And this will have 3 rows and 4 columns. So the upper leftmost index will be at 0, 0, which is just like the origin of the Cartesian plane. So let's say we are trying to reference this element right here. So we would go down to the first row, and you might be a bit confused because it looks like the second, but remember it starts at 0, and the second column, which again looks like the third, but also starts at 0. Now, if you were trying to populate this, let's say you started with an empty 2D array, and you had some sort of loop, which we'll learn about in the repetition structures video, then typically you would go through each row and fill all these columns individually. I'll show you a bit more during repetition structures, but that's something that's good to remember. That's it for this video. If you have any questions or comments, feel free to email me at edan.parker@queensu.ca. Thanks, and see you next time.